Seen from above, a container port looks like more than a terminal. It looks like an entire city built from blocks of steel. Massive ships arrive carrying stacks that rise like buildings. Cranes as tall as skyscrapers stretch across the deck, while trucks move through narrow corridors, and thousands of containers are lifted, transported, and repositioned with precision. From a distance, it all looks like a wall of nearly identical boxes. But within this operation, every container must leave in exactly the right order. Some have reached their destination, others will continue their journey, and many are trapped beneath tons of steel. That raises a seemingly impossible question. How does a port find the exact box it needs among thousands of nearly identical containers? And one detail makes this story far more personal than it seems. Inside one of those boxes could be headphones you ordered, a part for your computer, or a shirt from Shine made on the other side of the world. To you, it is just an order in an app. To the port, it has vanished inside a colossal operation. Today, you will discover how massive ports transform this apparent chaos into a sequence organized down to the inch. Here on Invisible Structures. To grasp the true scale, consider the Megaprojects. During an operation at the Pasir Panjang terminal in Singapore, PSA recorded 12,482 container moves in just 34 hours, using 11 cranes. Each move represents a container being unloaded, placed aboard, or repositioned. While some boxes leave, others remain on the ship, and new ones fill the spaces they opened. If the sequence is wrong, cargo can become trapped beneath tons of steel, forcing machines to repeat movements and delaying trucks, trains, and even the ship's departure. But the answer to the original question is not what it seems. The port is not searching for your package. It is searching for the identified container carrying the shipment your package belongs to. And long before the ship appears on the horizon, that box has already reached the terminal in another form, as information. Before it becomes a visible box at the port, the cargo already exists as data. At the origin, a factory, exporter, or logistics center prepares the goods and records details that may seem bureaucratic, but form the true map of the journey. What is being shipped? Who sent it? Who will receive it? Its weight, origin, destination, vessel, and the port where the container must be unloaded. Before the ship arrives, the terminal has already received files, docking forecasts, and cargo lists showing which units will be loaded, unloaded, or remain aboard. The port mainly tracks the container's identity. Every box carries a unique code, along with its owner, category, and dimensions. It also receives a numbered physical seal on the door. If that seal does not match the documents, the entire system raises an alert. Now, consider consolidated cargo. A single container may hold goods from several companies. Inside could be small boxes, pallets, parts, coils, or packages headed to different destinations after it is opened. But to the port, the main character is not each individual package. It is the larger unit, the container, because that is what the crane can lift, stack, and hand off to the next stage. This system only works because these boxes follow standardized dimensions. A 20-foot container equals 1 TEU, the unit used to measure ship and terminal capacity. A 40-foot model is twice as long and equals 2 TEUs. So when a ship lists a capacity of 18,000 TEUs, that does not necessarily mean 18,000 physical containers. Inside the ship, every unit also receives a precise address. Not a street and number, but a position aboard the vessel. The stowage plan identifies the container's bay, its lateral row, and its height within the stack. In other words, the box has coordinates inside this city of steel. It is not somewhere on the ship. It occupies a known position linked to a destination and an operational sequence. But knowing the address does not solve the whole problem. If the container sits at the bottom of a stack, other boxes may need to be removed first. If it is too heavy, it cannot be placed just anywhere, because weight distribution affects the ship's stability. Hazardous cargo must follow separation rules. Refrigerated cargo must remain powered and monitored. And if it is headed to a later port, it cannot be buried behind cargo that must be unloaded first. This is the part almost no one imagines while checking a tracking app. The package seems to move from one point to another, but behind that journey lies a chain of decisions made by shipping lines, freight forwarders, terminal operators, and interconnected systems. The individual product disappears inside the container, but its documented identity remains alive. So the container is not found when the ship arrives. It was never unidentified. The real challenge is removing it in the correct sequence, without disrupting the rest of the voyage. It is like extracting one piece from a three-dimensional puzzle, knowing the pieces above it weigh tons, and the entire game must keep moving. Once the plan is set, the digital map must become physical force. When the ship reaches the dock, it is not completely emptied like a suitcase opened on the floor. At every port call, some boxes leave, others stay aboard, and new ones fill the spaces created. The port performs a cargo exchange. The plan must balance three tasks at once: unloading cargo that has arrived, preserving cargo continuing onward, and loading what has just reached the terminal. The first scene feels almost medieval, despite all the technology surrounding it. Before cranes attacked the stacks, crews and machinery handled the lashing rods, tensioners, and locks that secured the containers during the crossing. At sea, each stack faces wind, rolling, vibration, and waves. If those restraints fail, cargo weighing tens of tons can shift, damage other boxes, or even fall into the ocean. So before unloading can begin safely, workers must first release what was fastened down to survive the sea. Then, the giants of the dock take over. The crane positions its spreader above the container. The device locks onto the box's four upper corners, confirms the connection, and only then lifts the load. From a distance, it looks simple. Lower, lock, lift, and move. Up close, it is a dance controlled within inches, guided by operators, sensors, signals, weight limits, and programmed routes. If the target box is on deck, the crane can reach it by first removing the units above. If it is inside the hull, enormous hatch covers must be opened after the upper stacks are cleared. Below are more containers fitted into vertical cells like giant steel drawers. The ship is not a random pile. It is a structure designed to hold boxes in calculated positions, so weight remains balanced and access follows a sequence. The crucial detail is that cranes do not choose what to remove by instinct. They follow a movement list prepared in advance. While one crane unloads one area, another may load containers elsewhere, as long as the machines do not interfere and the ship's overall stability stays within limits. One wrong decision can trigger a logistical domino effect. Removing a box too early can block equipment, force extra repositioning, or leave an important container inaccessible while its truck is already waiting. This is where efficiency begins. A port's speed comes not only from the crane's power, but from the order of every movement. Each box removed prepares the next. Each space opened can receive new cargo. Every unnecessary move costs time, fuel, labor, and dock availability. At massive ports, lost minutes become lines of trucks, delayed trains, ships waiting offshore, and goods stalled far from store shelves. There is also a common myth. Many people assume that once their package reaches the country, it is almost in the delivery driver's hands. In reality, it may only be leaving the ship. The container still has to touch the dock, be identified again, transfer to an internal terminal vehicle, and receive a new address in the yard. The correct box finally leaves the ship, following a sequence built in advance by people, documents, and systems. But that does not mean it is close to the exit. On land, an even larger maze begins. And if you enjoy discovering how these massive structures work behind seemingly simple processes, subscribe to Invisible Structures. Removing the container from the ship is only half the challenge. Now it must cross a yard filled with thousands of boxes without disappearing into the wrong place. As soon as the container leaves the crane's spreader, it enters a world that looks far more organized from above than from the ground. The terminal yard may hold thousands of boxes stacked in blocks, rows, and tiers. From the outside, it is a colorful wall of metal. To the system, every position has an address, an expected departure time, and an operational consequence. Placing the box in any open space would guarantee delays. Imagine a container must leave in 3 hours, but is placed at the bottom of a 5-unit stack. To free it, the terminal would need to remove the 4 boxes above, set them somewhere else, retrieve the correct box, and then reorganize everything. These extra moves are called reshuffles, and modern ports constantly work to avoid them. That is why a container's yard position depends on many factors. When must it leave? Will it travel by truck, train, barge, or another ship? Does it need inspection? Has its paperwork been cleared? Is it refrigerated and in need of power? Does it contain hazardous cargo? Is it too heavy for the top of a stack? Will it remain for days or only a few hours? Every answer changes the ideal location. The yard is a puzzle in constant motion. Unlike an ordinary puzzle, its pieces arrive and leave non-stop. One ship unloads, another docks, trucks enter, trains are assembled, refrigerated containers require constant monitoring, and transshipment cargo waits for its next connection. Every minute, the map changes. At this point, the package may seem found, yet it can still remain operationally hidden. Not because the system lost the box, but because poor placement can make it difficult to access when pickup time comes. Knowing where it is does not mean reaching it efficiently. That is why some terminals use management systems that suggest the best stack, reserve positions, and reduce unnecessary moves. At highly automated terminals, guided vehicles and yard cranes transport and stack containers by following digital instructions. Elsewhere, human operators and crewed machines perform the work with support from screens, radios, and sensors. In every case, the goal is the same. Place each box where it can leave at the right moment with as few handling moves as possible. Good positioning prevents equipment from traveling unnecessary distances and keeps a truck from reaching the gate while its cargo remains trapped at the bottom of a stack. Finding the container aboard the ship is only part of the problem. The greater challenge may be placing it correctly on land, so it does not need to be moved repeatedly before leaving. The box is located, accessible, and perhaps only a few yards from the gate. Even so, it is not yet authorized to leave the terminal. Before leaving the port, the container crosses a barrier almost no one sees: the documentary, customs, and security barrier. The terminal knows where the box is, but that does not mean any truck can enter and take it. First, declarations, manifests, records, seals, and clearances must all match. Customs does not open every container. Instead, it assesses risk, compares information, selects cargo for scanning, inspection, or detention, and releases the rest once the documents pass inspection. This prevents the port from becoming an impossible bottleneck. Opening every container would be like reviewing every page in a library before lending out a single book. Instead, the system cross-checks warning signs: origin, destination, cargo type, shipment history, weight discrepancies, seal integrity, importer data, and local rules help determine what requires special attention. Once clearance appears, another layer of control takes over. At the gate, the license plate, appointment, documents, electronic authorization, and driver's identity must match the pickup request. The terminal confirms the job, locates the box in the yard, and dispatches the correct machine to retrieve it. Only then does it continue by truck, train, barge, or another vessel. Even then, the system records its departure because the next link in the chain must know responsibility has changed hands. But your order has still not reappeared as an individual package. Often, the container leaves the terminal sealed and is opened only at a logistics center, warehouse, or importer facility. There, the goods are separated again. The shipment becomes pallets. The pallets become boxes. The boxes become orders. And each order reappears in the delivery system you track on your phone. That is the final twist. No single system tracks the entire journey alone. The port tracks the container. The logistics operator links the cargo to that box. After separation, the carrier tracks the package. Each stage preserves part of its identity and passes the information to the next. Meanwhile, the Megaprojects receives new containers in the spaces that were cleared. The weight is redistributed, the stacks are secured again, and the ship leaves Singapore with a new cargo configuration, ready to repeat the same operation at its next destination. So the next time your tracking status says, "Arrived at port," remember this. Your package crossed a city of steel, guided by an invisible sequence of identification, access, authorization, and delivery. No one found it by searching for your name among thousands of boxes. It arrived because every link knew exactly which unit to receive and which one to pass forward. If this video changed the way you see ports, subscribe to Invisible Structures and tell us which details surprised you most. After all, the world's greatest structures are often the ones that work so well, almost no one notices them.